Hi, ladies and gentlemen. This is Mr. Green again. This is another in my series of recordings for AP Statistics. We are looking at chi-squared, and we're not looking at chi-square 1. We're looking at 10.02. The difference between 10.01 and 10.02 is we're going to have two-way tables now, rather than just one-way tables. So it'll be slightly different what we're looking at. Once again, this fits into the AP statistics stuff that we're looking at. We're still going to do an inference for the least squares regression line. Okay? So, what we're looking at when we're looking at two-way tables is we're trying to determine, are the data associated or independent? That's what we're really looking for. We're not trying to know about whether they're all equal or anything like that. We're trying to say, are they related or not related? Okay? So what we're saying is we're going to try to look at the data and say, yes, it's related, or no, it's not related. Okay? If knowledge of one variable gives information about the other, then they're not, or gives information about the other, then they are related or associated. They are not independent of each other. If knowledge of one variable gives no information about the other one, then they're not related, not associated, and they're independent of each other. This is what you're trying to say. They're not independent or they're independent of each other. That's what we have to try to determine. So when we compute the chi-squared statistic, we're still using this same formula here. The problem is we've got a two-way table, and they're much, 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 much bigger. Okay? So what we're going to do is a little bit of trickery to make certain we get it to work. Okay? So what we're going to have to do is we're going to have to look and see, based upon our H0, is to how much the data is independent of each other. You need to make certain you state that as words. So our H0 is going to be that the data is independent. Our H alternative is the data is not going to be independent. Okay? Our degrees of freedom, which the chi-square is based off of, its degrees of freedom, you're going to take the number of rows minus 1, the number of columns minus 1, and multiply those two together. Okay? So how do we calculate the expected values in a two-way table? It's really not that difficult to do. Okay? What you're going to do is you're going to take the total of the rows and the total of the columns, you're going to multiply that together and divide it by the grand total of everything that's there. It works out to be fairly simple to do for any one little column, any one little table that you're looking at, but you just need to know how to calculate that because there are some questions about that. So, the null hypothesis, the variables are independent, or there's no association between the variables. Make certain you state that in terms of what the question is. The alternative hypothesis, the variables are not independent, or they are associated. So, you need to confirm that all the expected values are at least 5 again. Okay? And I'll show you how to do that too. So, state the null and alternative hypothesis and conclusion in the context of the problem that you're looking at. Don't forget to do that. That will make a huge difference. So, here we've got a table. Did I forget to put a separate one in there? I did. Okay, so here we've got a little table. So, H sub 0, the null hypothesis, the values are independent. The alternative, they're dependent upon each other. So I'm going to show you how to calculate these values. So I'm going to take 35 plus 101 is 136. That's 140. That's 168. Going down. Going across, if I pick on this one right here, this 101, I'm going to get 730 going across. So to find the expected value right here, what I'm going to do is I'm going to take 168 times 730, and that's going to be divided by, and I'm going to have to add these up real quickly because I don't have a grand total. 35 plus 101 plus 28 plus 4, and 168. I added that right. Okay. 147 plus 629 plus 222 plus 34 is, oh, there's 1,200 here. So we're going to divide that by 1,200. Okay? So let's take these numbers and figure out what we got. 168 times 730 divided by 1200 gives me 102.2. So my expected value right here is going to be 102.2. Uh, couldn't see that. 102.2. That's how I calculated that expected value. But you know what? That's not what we do. Even though that we know how to calculate those, we're typically going to use a calculator to do it. And we can use a calculator very easily. And I want to show you how we're going to do this. Okay? Oh, come on. Thank you. So here's what I'm going to do. I'm going to clear my calculator out. I'm going to press second matrix. Yes, we're going to use matrix math to do this, okay? I'm going to go over here to edit and hit enter, and we're going to edit number 1. There are 4 rows and 2 columns. 4 by 2. In case you forget that, you can see it makes 4 rows and 2 columns, so you can look at it and say, oh, I'm getting them in the right order, okay? So that first number is 35. The next number is 147. The next number is 101. The next number is 629. Next number is 28. 222. 4. And 34. And you hit enter. Okay, so we now have those numbers out in A. In case you want to make certain you have them right, matrix, and you can just press A there, and it'll print them out for you. Make certain you've got them in there correctly. Always helps to make certain that you've got them correct, because if you make a mistake here, it really affects your results. Okay, what we're going to do is we're going to press statistics. We're going to go over to test. And we're going to go down to C, chi-square test. Chi-square test, and press enter. Notice how it's got A here for the observed and B for the expected. But Mr. Green, we didn't put anything in the expected. Don't worry. It will calculate the expected for us. And it gave us a chi-square number of 6.16 and a p-value of 0.104 with a degree of freedom of 3. Are these what we expected? Well, 4 minus 1 is 3. 2 minus 1 is 1. 3 times 1 is 3. So yes, my degree of freedom is what I expected. It gave me a 10% percentage is in the area to the right, okay? And our chi-square number is 6.1816. But I said we need to make certain we check those expected values, make certain they're all over 5. Watch what I'm going to do. Second matrix. We're going to look at B. Remember, B was where the expecteds were. And when I press enter for B, it gives me what the calculated expected values were. Look at this, 102.2, 102.2. Aha, I got that one correct when I calculated it. It gives you these expected values right there. And we don't have to do any work to get them if we're using the calculator. Okay? You saw what I did there, right? Made certain you understood it, because you might need to back up and watch how I do that matrix stuff again. It's still a little bit new for some people. Okay, so that's how we got the expected value. I calculated it right here. The expected values are all greater than 5. The smallest one's 5.32, and it occurred right there. Okay, my p-value was 10.104, degree of freedom 3. Okay, my chi-square value is 6.16. So what does that mean? If you drew the graph, remember, graph tailing off to the right, 6.16 is the value that you're getting, and the percentage here is this 10.4. There's not enough evidence to reject H0 because it's not less than that alpha of 0.05, right? At a 0.05 level. Not enough evidence to reject H0. So, are they independent? Yes. They're not dependent upon each other. They are independent values. And I have no idea what these represent. I mean, you got to make certain you state these in terms of whatever they are, but I was just using this table as an example. Okay? So, once again, I'm still teaching, giving star tests and on this week. So I'm not going to be available to answer your questions this week, and I want you to make certain that you send them to me via Kmail, and I'll get back in touch with you as quickly as I possibly can. Okay? Make certain you're always including the fact that you're in AP Statistics. Otherwise, it makes it more difficult for me to answer your question. Well, chi-square questions I'll probably understand. Okay, I look forward to seeing you next time.